Why, hello, good afternoon, and welcome to science class. This week we've been talking about crystals, minerals, non-living, right? Hello, are you alive? Hello, can you hear me? No, it's not alive. It's a rock. It's not alive. That forms into a crystal shape. This is a beautiful one. Lying around the house. Here's another one. Um, I have to say, not as pretty. Oh, up here. There you go. This one's more just like you can see it's stuck into other rock. A little dirty too. That's okay. It's from the ground. Um, all right, what we're gonna do right now, I just want to go over the end of this section, pages 420, 421, 422, which is stuff that you were supposed to all fill in. I just want to go over that with you real quick. 420. This one, number one, minerals are non-living solids. We've proven that. I talked to the crystal. It did not talk back to me. It is not alive, non-living. Non-living solids that have crystal shapes. Garnet crystals are shaped almost like soccer balls. According to my special teacher's edition, the answer is C. Does that look like a soccer ball to you? No, it does not. Science. Number two, a mineral's hardness can help to identify it. Fluorite has a hardness of 6. It can be scratched with a steel nail. Why, look, there's someone right now scratching it with a steel nail. I imagine that if you're a geologist, you do that a lot. You take nails and scratch rocks. So consider being a geologist if you like that kind of stuff. Number three, different minerals reflect light in different ways. This property is called luster. Gold has a metallic luster. Which one's gold? Right. No, that's not right. It's D. There it is. Look how shiny that is. It's lustrous. Which is a nice adjective, lustrous. Number four, minerals that break in straight lines have cleavage. The mineral mica breaks into thin, flat sheets. There it is. There, breaking into thin, flat sheets. Say that 3 times fast, carefully. Number five, you can see a mineral streak color using a streak plate. Each mineral has a characteristic streak color. Graphite has a black to gray streak. There it is, leaving its streak color behind. Should we go to the next page? Let's go to the next page. Wordplay. I rock at wordplay. Oh, bring on the puns. Bring them on. You can find out a mineral's blank by seeing what other minerals it can scratch. Which one of those words up above? Hardness, right? That's one of the ways that you judge minerals is how hard they are, how you classify them, not how you judge them. We don't judge them as you are a bad mineral, you cannot scratch. We just classify them that way. Number two, a non-living solid that has a blank form is called a mineral. Crystal, we've established that. They're not alive, and they've got a crystal form, like salt, like sugar. You know, salt's lying, any other crystals lying around the house? Salt and sugar. Biggies. Number three, gold, silver, copper, and pyrite each have a metallic luster. Lustrous. They're shiny. Number four, fluorite, talc, diamond, gold, and quartz are all example of minerals. They're all minerals. The color left behind when a mineral is rubbed across a white tile is its streak. Streak, it leaves its streak behind. Number six, a mineral that breaks along straight, smooth lines is said to have what's left? Cleavage. Cleavage. That word also gets used in general geology. You can think of cleavage in rocks. Caused by erosion, that kind of stuff. And then all those little circular circles, you add them all up, and what'd you get? You got the word halides. Now there's excitement. Halides. All right. Make a list of the different properties that can be used to identify a mineral. How can we identify a mineral? Its hardness, using that Mohs scale. Its luster. What kind of shine does it have? Does it have a glassy luster? Does it have a metallic luster? And there's the third one. I can't remember what it is. I'm going to look back in the book. Can you guys remember? Metallic luster, shiny luster. If you can get it before I do it, you win a prize. Oh, I got it. Earthy luster. Ooh, the earthy luster. Like that. So there's 3 different kinds of luster. Metallic, earrings, glassy, although these are made of plastic, and earthy. Earthy luster. Sure. And then also, okay, so we got, in that section, make a list of the different properties. We've got the, its hardness, what can it scratch? Its luster, how shiny is it? Its streak, what color it leaves behind? Its cleavage, does it break in nice thin, nice perfect sections? Or does it crumble like talc? And then its shape. Daniela had shared a video with us about how the shape of crystals is dependent on the kinds of atoms that are formed together. It's a pretty cool video. Hope you all checked it out. Kind of blew my mind with the square crystals and the square atoms all forming together. Number 3, let's look at that section. Magnetite has a metallic or earthy luster, a gray-black streak, and a hardness of 5 to 7. Circle the mineral that is most likely magnetite. So let's look at the 3 options. The first one says, this material can scratch talc, but not calcite. So if you can scratch talc, that's 1. Everybody can scratch talc. But it can't scratch calcite, which is number 3. Which means that this is a number 2. If I move my finger here somewhere. It's a number 2. So we know that we're looking for magnetite, which is a hardness of 5 or 7. So it's not that one. How about the second one? This mineral can scratch apatite. Apatite? Wow. I need to scratch my apatite. 5, but not quartz. 7. Oh, so that's like 6. It's stronger than 5, can scratch that, but not as strong as 7, so 6. So this is probably feldspar. This mineral can scratch apatite, that's good. Apatite, 5 again, but not quartz. It says the same thing. This mineral can scratch apatite, but not quartz. Oh, they made... Oh, well, curious. Oh, so... Oh, it's not about the hardness at all, if we look at it. The trick is the color, because it says it leaves a gray-black streak. Well, it can't be that one, because that's not gray-black, that's like a copper color. So it has to be this one, and because it has a hardness of 5 to 7, so it does fit. This is our answer right here. That is magnetite. Let's hear it for the magnetite. 4, which part of the description helped you identify the mineral? No, I disagree. The hardness told me which mineral was the correct choice. The hardness did, but it was the color, it was the streak that made us understand which one it was. Which mineral did you roll at first? How? The second one. It doesn't have a gray-black streak. Well, we rolled out the first one first, because we looked at the first one. It was way too soft. Because it can't even scratch calcite. I mean, give me a break. You can't scratch calcite. All right. That was our first section. This week, I want you to finish up this chapter. We're going to burn right through this chapter. 1 chapter a week. What the heck? So, the next section of this chapter is, I'm turning the pages, 427, all the way through, all the way through the rest of this chapter. What the heck? Uses of rock. We're going to make it, and then how about this? At the end of this chapter, people, there is a Unit 9 review. I'm going to ask... Ooh, showing you the answers. Oops, I wasn't supposed to show you the answers. Let's finish that. That's me homework for this week, is to finish the Unit 9 review. And then we'll go over that later this week. All right, hope you guys are doing good. Bye. Oh, Rock says goodbye. Goodbye, Rock. Goodbye. So long.